This is El Profelo. In this video, we're going to be talking about vectors in a plane, the component form and vector addition. We'll look at magnitudes and directional angle, as well as trig applications from vectors, including area, sine rule, bearing, and compass bearing. Okay, so here we have a diagram with the quadrilateral and some given vertices. So we'll go through and work through the items that we're told to find. Okay, so to start, it asks about finding this vector from A to C. Right, so we're looking for that vector. One way that we can do this is by knowing that A to C is going to be given by x2 minus x1 and y2 minus y1, right? So just the change in x and the change in y. Well, another way that we can look at that is we can say, hey, if here is point A and here is point C, what's it going to take to move in those directionalities, right? What's it going to take to move in those directionalities? Well, I know this is the form. Well, to go from 1 to 5 is 4 units. To go from 0 to 2 is 2 units. So then we know that A to C has to be equal to 4, 2. Okay. Now, what about the magnitude, right? Well, the magnitude of A to C, we can simply use the Pythagorean theorem. And so that would be the square root of 16 plus 4, which would be the square root of 20, which we could simplify to be 2 square roots of 5. Okay, pretty straightforward for those items. If we wanted to, we could do this for other points as well. If we wanted to do this for other points, all right, well, from A to D, or other vectors, excuse me, A to D, all right, I could write as, well, going from point A to point D is going to be move 3 in the positive x direction and move 1 in the negative y direction. Okay, and for D to C, let's say, well, for D to C, we could move, let's see here, from D to C, that's going to be moving 1 in the positive x direction and then 3 in the positive y direction. Okay, and of course, we could say, well, what would be the magnitude of A to D? Pythagorean theorem. And what would be the magnitude of D to C? Pythagorean theorem. All right, so here we have different setups that we have to be able to determine information for this quadrilateral. Okay. What about B to D? B to D is going to be this directional vector coming from B down to D. And we want to find its component form and we want to find its directional angle. Okay, well, the component form of B to D, right, we can look at, once again, here is point B, here is point D. All right, we see those pieces, and so we know that B to D is going to be x2 minus x1, so that's 4 minus 1, and then y2 minus y1, that's negative 1 minus 5. All right, so we know then that B to D in its component form is going to be 3, negative 6. If we wanted to find the direction angle from B to D, if we wanted to find that directional angle, we could think of, well, here is point B, here is point D. If I'm traveling in that direction, all right, what's going to be the angle that I make with the horizontal for my directional angle? Well, the relationship is that the tangent of alpha, that angle, is going to be equal to y over x. So that means that the tangent of alpha is equal to negative 2, right? And finding the inverse tangent, we would get about negative 63.4 degrees. Okay. Note that that's the directional angle. If we were to ask about the bearing would actually be to go from north all the way. And so that means that the bearing would be 90 plus 63.4, and 90 plus 63.4 is 153.4 degrees. All right, so you always want to be careful about what's being asked, right? And which direction am I measuring from? Okay. Now, what if I want to find an angle from an area? What if I want to find an angle from an area? All right, so let's say I know information about that triangle there, and I want to find information on this angle right here. We'll call that ADC. Okay, and let's say that triangle ADC has an area of 5. So that means that 5 is going to be equal to 1/2 the 2 sides of the triangle times the sine of the included angle of the triangle. All right. Well, that implies that 5 is equal to 5 sine of theta, which means that sine of theta is equal to 1, and that would mean that theta is 90 degrees. Okay? That's how we can find an angle from an area. All right. How did we get 90 degrees? We simply say the inverse sine of 1. All right. Now, what about finding an angle from the sine rule? Okay. So let's come over here and let's say that this angle right here, let's call this angle gamma. Okay. So with that angle gamma, the sine rule would tell us that the sine of gamma all over the square root of 10 has to equal the sine of theta all over the square root of 20. So therefore, the sine of gamma is going to be equal to square root of 10 times 1 all over the square root of 20, which is the same thing as the square root of 1/2, which is the same thing as the square root of 2 over 2. So therefore, gamma has to be 45 degrees because we know that that's the ratio for a sine ratio for an angle of 45 degrees. We could, of course, do this using our calculator. We could have done this using our calculator, and we could say, okay, well, what's the square root of 10, right, sine of 90? Right, make sure that we're in degree mode. Okay, and take that number divided by the square root of 20. Right, and then do the inverse sine of that ratio. And notice we get the 45 degrees. Okay. Of course, this particular problem, if we knew that this angle was 90 degrees and we knew that this was an isosceles right triangle, we should be able to determine without any of this sine rule that that's 45 degrees. But that's not always going to be the case. Okay. And then the bearing and compass bearing, right? Let's do the bearing and the compass bearing from A to D, okay? If I want to do the bearing and the compass bearing from A to D, here's what I can set up, okay? Well, let's look at our points. We'll say, hey, here is our graph, right? Here's going from A to D. And if I want to know my angle, right, I could find this directional angle right over here, okay? And I could also find, right, the bearing would be doing the entire angle. So let's come over here and just call this angle right in there phi, okay? Because we know that the bearing is going to end up being 90 degrees plus that phi. Well, what do we know about phi? We know that the tangent of phi is going to be equal to -1/3. Now, some of you may ask, what do you mean? How is it from -1/3? Well, the way we know that is because a to d has an x component and a y component, and we simply do the y divided by the x. All right? Solving for phi is equal to -18.4 degrees. All right? So therefore, the bearing would be 108.4 degrees. Why 108.4 degrees? Because the bearing would be taking all of that. Okay. And the compass bearing, right? If I wanted to do the compass bearing, that's going to need to be an acute angle from north-south line. And so that would take us in that direction. Okay. And the compass bearing, therefore, would have to be south 71.6 degrees east. How did we get that? Just by saying 90 minus 18.4. Okay, so that works with a bit of things in trig applications and in vectors. All right, we have the vectors in a plane, we have the component form, the vector addition, the magnitude and direction angle, all those various things. Okay, so this was El Profilo. If you have questions, please reach out.